Okay, day 2. We're on the torque question sheet. Numbers 5 and 6 would be the next two that we would have done for homework if we were in school. So here are the solutions for whenever we might get to them. So number 5 says a 5-meter long ladder. So this whole thing is 5 meters long. Means it gets a wall at a 0.4 meters above the ground. So this is 4 meters. So from the hypotenuse on the opposite side, you can find this angle, right? It'll be sine, inverse sine of 0.8 should be 53.13, I believe. Okay, then it says the ladder is uniform, has a mass of 12 kilograms, so the mass of the ladder is 12 kilograms, and because it's uniform, it means Fg of the ladder is acting halfway along its length. Okay, and then it says a firefighter of mass 60 kilograms, so just a little guy, it's 132 pounds, is climbing the ladder to put the fire out that seems to have started among some papers and a partially completed physics assignment on them. Whew, no wonder the fireman is running up this ladder. Okay, the ladder begins to slip when the firefighter is 70% of the way up. So this is Fg, and I'm just going to call him a person. And this length is 70%, so 70% of the 5 meters. If the wall is frictionless, what is the coefficient of static friction between the ground and the ladder? So putting in our other forces, we're going to have right here an sorry, that just looks like friction, an F normal of the ground. Sorry, my iPad beeped and I didn't know what it was. And down here we're going to have an F friction of the ground. And up here we're going to have an F normal of the house. Just seeing what it was leaning against. And it says we can ignore friction at the top. So we were looking in the end for mu, and so we're of the ground. So we're going to use 3 equations. Our sum of the forces in the x direction, our sum of the forces in the y direction, and our torque. So sum of the forces in the x direction will be easy, and all 3 of those are going to be equal to 0, because there's only 2 forces in the x direction. There's friction on the ground minus the normal of the house equal to 0. So we can't find these, but what we can find is that they're equal to each other, which will come in handy when we get to sum of the torques. Okay? So then we go to sum of the forces in the y direction. And if you're wondering why I started with x, it was because I knew I had enough room right there to do it. In the y direction, we have F normal of the ground going up, the weight of the ladder going down, and the weight of the person going down. And they again have to give us 0. Always in the y direction, you're trying to solve for Fn. So it'll be equal to, take these 2 over and they become positive. So m of the ladder g plus m of the person g. And you could actually find this because we have the masses of both. So 12 and 60, and you could fill it in. But I'm just going to carry it to show you how to carry it, okay? So, because we've been carrying them all along and not filling them in. So let's do that for this one. It's fine if you didn't. If you actually filled it in, it would be what, 72 times 9.81. You would get 706, I think. So just in case you filled it in, F normal of the ground would be 706 point something, 32, I believe. 72 times 9.81. Okay, so if you filled it in, that's what you get, but let's carry it just for fun. All right, so then we would go to sum of the torques, also having to equal 0. And if you look, there are 5 forces, 1, 2, 3, 4, 5. So you start out by writing down the 5 torques. So normal of the ground, friction on the ground, normal of the house, the ladder, and the person. Okay, and then you have to decide where do you want to pick your pivot point. And really, you can pick it anywhere. But in the case of the ladder, there's always going to be an easier spot and harder spots. The easiest spot is right down here at the bottom. It's easiest for a couple of reasons. One, because usually you're given your distance with respect to the bottom. Two, because if you were on this ladder and you imagined it was about to rotate, it would rotate probably around this point. Like if the wall gave way, this end would fall down, right? So that's the second reason it's easiest. Third reason it's easiest is because if you pick it down here, these two forces that go through the pivot point are going to have an R of 0. Their lever arm will be 0, so they'll go to 0. And it'll leave us with just 3 torques. The fourth reason it's easiest is because the angles are easiest to find down here. Sometimes people will pick it up at this spot because they want to get rid of this one. Well, okay, that's all fine and good, except now you have these two that you also don't know. And the angles will all be different because, like, when we pick it down here, our angle between the R for the ladder and the F for the ladder would be right here. If we picked it up at the top, the angle would be this big guy, and that always causes issues. So I would highly recommend picking it down at this bottom corner. And I've been doing this for a year or two, so I would suggest, and I know you're all adding up how many years that really is. It's probably more than you've been alive. So trust me, down here is the easiest spot. All right, so down here then, we now have to find directions. So hold your writing utensil, lie it along the thing that's going to rotate, hold it at the pivot point. F normal of the house is going to cause it to rotate that way, and the two weights are going to make it cause to rotate this way. This way is clockwise, they'll be negative. That way is counterclockwise, they'll be positive. So it's going to be positive, negative, negative. So it'll be R normal of the house, F normal of the house, sine theta normal of the house, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the person, FG of the person, sine theta of the person equals 0. Okay? So then take a look at your angles. None of them are 90. None of them disappear. And what we're trying to solve for is this F normal of the house. So F normal of the house will be equal to, take these two guys over and they become positive, R of the ladder, M of the ladder, G, sine theta of the ladder, plus R of the person, M of the person, G, sine theta of the person, and then divide by R normal of the house, sine theta normal of the house. Okay, and so you can fill your numbers in. R of the ladder. It told us it was a 5 meter long uniform ladder, so the center of mass of the ladder should be halfway along its length, or 2.5 meters. It told us that the mass of the ladder was 12 kilograms. And the angle between the R of the ladder and the F is this guy right here. If the bottom one is 53.13, then that top one must be its complement, 36.87. Plus, R of the person. 70% of the way up a 5 meter long ladder will be 3.5 meters. Mass of the person, 60 kilograms. And the angle for the person, again, between the R and the F, so again it's this top corner. The one with the bottom, with the ground would be 90. This one down here is 53.13, so it has to be the complement. So this will be 36.87 as well. Divide by R normal of the house. From the pivot point all the way up to where the force of the normal of the house is 5 meters. And the angle for the normal of the house between the R, which is along the ladder, and the F normal of the house is this guy.